Waste Warriors is a non-profit organization catalyzing systemic change to solve the waste management crisis of the Indian Himalayan region. As a grassroots organization, currently working out of the Indian states of Uttarakhand and Himachal Pradesh, our work lies at the intersection of climate change mitigation, biodiversity habitat conservation, and dignified livelihoods. With a team of over 200 plus warriors, we strive to enable access to effective waste management services in urban and rural areas, with a special focus on eco-sensitive and tourist areas. The Indian Himalayan region, due to increased tourism, among other factors, is facing a major environmental challenge. Anthropogenic emissions of greenhouse gases like carbon dioxide and methane are on the rise. Open burning and dumping of municipal solid waste is generating carbon dioxide and methane in addition to black carbon, a significant source of pollutants, leading to the faster melting of the Himalayan glaciers and thereby reinforcing climate change. Plastic pollution, on the other hand, has reached everywhere, from the highest point on land, Mount Everest, to the lowest point in the sea, Mariana Trench. Unfortunately, the marginalized communities and the voiceless wildlife in these eco-sensitive regions are the most vulnerable to the impacts. This is the war we at Waste Warriors choose to fight every single day, and as long as it takes to find an inclusive, participatory, and sustainable solution to the waste management crisis in eco-sensitive areas of the Indian Himalayan region. Today's discussion will focus on capturing the reduced greenhouse gas emissions through improved solid waste management, insights from the Indian Himalayan region. Organized by Waste Warriors Society in collaboration with ClimateRISE Alliance, this webinar brings together professionals working in the waste management and climate action space, including researchers, policy experts, government agencies, NGOs, development partners, philanthropic organizations, and students. The discussion will cover GHG emissions accounting, its limitations in the Indian context, and pathways to strengthen climate-smart waste practices. To that end, I'd like to introduce our first guest speaker, Dr. Sunil Kumar, Chief Scientist at CSIR NERI, National Environmental Engineering Research Institute, a premier constitute laboratory of the Council of Scientific and Industrial Research under India's Ministry of Science and Technology, headquartered in Nagpur, India. Dr. Kumar is an IIT Kharagpur alumni who has led extensive research on waste systems with over 280 plus publications and global recognition, including being ranked among the top 2 scientists worldwide. Dr. Kumar has served on international committees, guided multiple PhD scholars, and brings deep expertise on solid waste management and its climate impact. Today, Dr. Kumar will touch upon overview of India's waste landscapes, key drivers, methodological considerations, and sectoral opportunities and challenges. Over to you, Dr. Kumar. You have around 5 minutes.
Good morning and good afternoon to everybody. I have to explain all my experiences of 29 years in 5 minutes. So I have highlighted my presentation under the 4-5 categories. So what are the experiences, challenges, and key consideration in greenhouse gas emission in waste sector, which is one of the hot topics against the backdrop of climate change, net zero, and sustainable development goals. Next one, please. So current waste sector, India is generating a lot of amount. I don't want to tell the figures. This figure is not going to be the right figure right now because it has increased multiple times, and still there is a lot of organic fraction, 45 to 45%, and this segregation is very low, and informal recycling workforce is playing a critical role in our country in solid waste management system, which is being ignored again and again. What are the key drivers of sector evaluation? Urbanization and demographic shift is increasing, and under the different initiatives, right from Swachh Bharat Mission, Jawaharlal Nehru Renewable Mission, Amrut, and the Smart City, these policies are focusing on sanitation and waste processing. And now climate commitments has come. So this waste management and improved waste management system is one of the important factors which is going to reduce the greenhouse gas emission from waste sector. And there are various technological options, rise of waste to energy, biomethanation, circular economy concepts under the different umbrella of plastic waste, e-waste, C&D, and biomedical waste management tools is going to change the scenario. Coming to the methodological consideration for waste sectors, quantification and characterization is one of the important aspects in GHG emission monitoring and this improved solid waste management. But the quantification and characterization after 2004, India does not have any realistic figure on quantification and characterization. All the greenhouse gas emission from waste sector is based on the secondary information, and segregation behavior in informal sector integration is also one of the important aspects which needs to be considered for this greenhouse gas emission and reduction. This emissions through recycling and energy recovery should be avoided. For what are the avoidance which should be accounted, and there are a lot of uncertainties in estimation methods for greenhouse gas emission scenarios under different categories, whether it is scope 1 direct emission, scope 2 direct indirect emissions, and scope 3 other indirect emission. And there is a cold climatic condition is very important, which West Barrier has raised this issue under the Himalayan regions. I think most of the people do not consider these aspects in emission monitoring and reduction. Next one, please. Key opportunities. There are a lot of technological interventions are coming up in this scenario for wet organic waste, and there is a scalable methane to energy conversion systems are going to be adopted at several parts of the country. Advanced MRF automation covering AI-based material recognition, bioreactor landfill development, which is now it has some biocell, which we are working under the sponsorship of DBTIC impact of Canadian counterparts, landfill gas capture systems, vertical and horizontal wells, which were applied earlier but failed. But these are the futures, and plasma gasification, refuse drives. Unless and until we go for integrated waste management system, we are not going to achieve the emission reduction as well as improved waste management system. But still, there are a lot of challenges. In spite of a lot of efforts through policy intervention, still source segregation is very low. Integration, every rule says that integration of informal sectors that is to be formalized, but it has not been done. High moisture content of organic this municipal solid waste, and land availability is very less, although there are a lot of efforts in the SBM2 and all other things, but there is persistent data gaps which are very much essential, and other aspects like behavioral change, municipal technical capacity, and financial resource limitations. These are continue to hinder large scale implementation of sustainable waste management section. Now, what are the way forward? We have to strengthen policy implementation and city level data system. From policy to this implementation, investment in MRF, decentralized composting, biomethanation, integration of informal sectors, and adoption of Tier 2, Tier 3 GHG estimation for climate planning, and then only we can transition towards resource recovery based waste economy rather than disposal centric system. Thank you very much.
Thank you, Dr. Kumar, for those wonderful insights. Requesting all participants to please write their questions in the Q&A chat box. Please note that we are reading your questions and it will be addressed by our experts in the Q&A part at the end of the webinar. Next up is our keynote address, Uncovering the Overlooked GHG Emissions from the Waste Sector, for which I'd like to introduce our second guest speakers, Paloma Genou, Program Officer, and Corinne Tromsdorf, Director at French Solid Waste Partnership. FSWP coordinates and amplifies the voice of French waste sector stakeholders for European international advocacy on waste prevention, collection, treatment, and resource recovery to promote a circular economy. Paloma is driven by a strong interest in the environmental and human rights dimensions of waste issues. At FSWP, Paloma contributes to the development of content and coordination of initiatives and stakeholders promoting waste prevention, improved collection, treatment, and resource recovery, supporting a transition to a more circular and sustainable system. Corinne Tromsdorf, an engineer by training, has built an international career in water and waste management across the United States, Switzerland, and projects in North Africa, Middle East, and Asia. For the past 2 years, she has served as an executive director of the FSWP, where she leads the platform, strategic development, and international positioning. Over to you, Paloma. You and Corinne have around 10 minutes.
Thank you. Hello, everyone. Let me just share my screen. There we go. Can you see it? All good? Great.
Yes,
Okay.
Paloma, we can see it.
So hello, everyone. I'm going to talk about GHG assessments and try to give an overview of the different methodologies to assess our GHG emissions from the waste sector. Niraj has already presented the French Solid Waste Partnership, so I don't think I'll spend too much time on this slide, but just to briefly complement, we're a multi-stakeholder platform where we unite all French stakeholders from the waste sector, so that is state and its agencies, local authorities, NGO and foundations, research and education, as well as private companies. And the overall mission is to accompany the transition to establish environmentally sound management of waste and resources everywhere, as well as accompany the transition towards waste reduction and circularity. So now, delving into our topic, today I'm going to briefly present some key data from the waste sector, and then delve into the topic of GHG assessment. I'll also briefly present the ISWA working group on climate change and waste management, and then I've left some slides for you if you're interested to go further and to read about key mitigation levers from the waste sector, as well as some resources to go deeper into these subjects. So the waste sector in 2016 has contributed to about 5% of global GHG emissions. We'll see in a minute that depending on who we're talking to, these numbers change. But under a business as usual scenario, the amount of waste generated by 2050 should increase by 70%. And mismanaged organic waste emits 20% of global methane. And we've seen during the last COP, for instance, that that's the main angle under which the waste sector is being analyzed at the international level. And waste prevention and circularity has the potential to mitigate to up to 20% of global GHGs. Now, talking about GHG assessment, we published a report a year ago that presents the global context, but also GHG assessment methodologies for solid waste management, as well as 3 types of levers to reduce these emissions. So technical levers, policy and regulatory levers, as well as financing levers. So feel free to scan this QR code and check out this report to learn more in detail about this, because I won't have time to go over it too much. So to start, what's the waste sector? Depending on whether you're talking to the climate community in general or to waste professionals, it means a lot of different things. And so for the community, the climate community, it includes wastewater management as well as waste management activities, but excluding waste to energy as well as recycling. And when we're talking to waste professionals, it's waste management activities as well as waste to energy. And depending on what we include, the amount of GHG emission contribution from the sector greatly changes. And this is especially true when we take into account the life cycle assessment approach, where you can see that when we take into account production of goods, the waste sector contributes to up to 15-25% of global GHG emissions. But what do we mean by GHG emissions? There's direct emissions, so these are scope 1, which are accounted for on the international scale the most often, as well as scope 2 sometimes, but most often for national reporting. Scope 2 is indirect emissions linked to the consumption of energy by an organization. And then there's scope 3 emissions, which are other indirect emissions. And in the case of France, for instance, the reporting of this scope of emissions has became mandatory since 2022. When the activities by a waste manager results in lowered GHG emissions, whether they're direct or indirect, it leads to reduced emissions. And it's really important to differentiate reduced emissions from avoided emissions, which are, when an organization's activities enables GHG reduction outside of its scope in comparison to a reference scenario. So here's an example of avoided emissions by France Plastique Recyclage, where there's production of recycled plastic that becomes substitute for primary PET, and therefore replacing fossil fuel usage. So that leads to avoided emission in an industrial scope. Now, for GHG assessment to be as efficient and important as it should be in, making our political decisions and acting in a relevant way in our local contexts, it's really important to be careful how we define our system boundary as organizations that have to report on GHG emissions. So here you can see that a first way of reporting is to base our system boundary on the activities owned by an organization. In this case, for instance, it means that the organization is only going to report on post-collection sorting and treatment, as well as energy recovery. But if the organization decides to report on the activities that are managed by this organization, it enables to take into consideration a whole new array of activities that are also emitting GHGs. So in this case, collection as well as safe final disposal are included in the accounting. You can see that recycling is excluded and is reported under scope 3 because it's often considered in the industry sector instead of the waste sector. So, and depending on the system boundary that is chosen, open burning and open dumping are going to be accounted for or not. So it's a very important decision to make. In France, there's a lot of guidelines that have been implemented to guide operators in assessing emissions. And in the publication I mentioned earlier, you can find in the annexes the whole guidelines that enable GHG assessment. So please feel free to check it out. So just as, to sum up, what are the key takeaways and why is GHG assessment so important? Well, first of all, it allows decision makers to identify the largest GHG emission sources. And as we know, accurate data allows for finer conclusions and therefore better decision making that is more locally tailored. And finally, GHG assessment allows to adjust mitigation actions and to monitor their impact. Another key takeaway is that assessing avoided emissions is really key in defining and guiding policy priorities and orientations, especially because they're so important in the waste sector through energy recovery and recycling. And not assessing them leads to, a dismissal of the waste sector as a potentially huge contributor to reducing and mitigating climate change. So now, and just building on these thoughts and notions, it sounds very important to join the ISWA working group on climate change and waste management, because it's where we could discuss this question and look for solutions to have a more locally tailored GHG assessment methodology and guide. So ISWA, if you don't know what it is the world's leading network which promotes and develops sustainable and professional waste management worldwide and the transition to a circular economy. And it has more than 1,300 members in 109 countries. Here you can see how it's structured. And at the bottom of my screen, you can see the different working groups. There's quite a bit, so I'm sure you can find a group that is interesting to you. And so the Climate Change and Waste Management Working Group in particular works on advocating for waste management and recycling to be better integrated into future international agreements, to promote the central role of waste and resources sector in reducing global GHG emissions and ensure that waste and circular economy are visible in climate fora. And I'm sorry, I'm a bit over time, but just to show you briefly, there's a lot of slides that show the different levers. So, prevention, moving away from open burning and open dumping, energy recovery, as well as material recovery. So please feel free to check out these slides after the webinar is over. Thank you for listening.
Thank you, Paloma. Those were some very, very interesting insights. Avoided versus reduced emissions have a clear distinction there. Thank you so much, Paloma, for that wonderful presentation. Again, requesting all participants to please write their questions in the Q&A chat box. Please note that we are reading all your questions and they will be addressed by our experts in the Q&A part of the webinar. In case we are not able to address all the questions in the Q&A section of the webinar, the experts will be responding to your questions and definitely be sharing them over to all of the participants over email at a future date. And now to dive in to Waste Warriors findings, I want to introduce our third speakers, Dr. Diksha Rana and Ashish Kapil from Waste Warriors, to share insights from the Indian Himalayan region. Dr. Diksha Rana is a research consultant at Waste Warriors, where she contributes to the research wing, as well as the knowledge management and storytelling on waste management and sustainability. She holds a PhD in environmental science and has over 3 years of academic experience in teaching and research. Ashish Kapil leads the monitoring and evaluation initiatives at Waste Warriors, where he builds centralized data systems and impact reporting solutions. With a strong background in data analytics, business intelligence, and stakeholder engagement, Ashish blends technical expertise with strategic thinking to solve complex problems. Over to you, Dr. Diksha. You and Ashish have around 15 minutes.
Thank you, Neeraj. Across the Indian Himalayan region, waste does not just accumulate, it travels, it burns, and it emits. And every time a dump site sits smoke in a valley or a gully fills with mixed waste, there is an invisible climate cost. It also leads to resource loss, pollution, and degrading soil and water in fragile Himalayan ecosystem. Today, we will take you through how improving waste system in these towns converts that cost into measurable climate benefits. Our intervention begins right at waste segregation, where we streamline door-to-door waste collection, supporting households, commercials, and different establishments to segregate waste. Over the last financial year, Waste Warriors prevented 1854 metric tons of waste from ending up in open dumping or burning across 9 locations in Himachal Pradesh and Uttarakhand. This number is important because it represents material that did not generate methane in dumps and did not release CO2 through burning. So by improving improved interventions like segregation, recycling, composting, and co-processing, Waste Warriors converts linear waste dumping into a positive circular system. Next, please. So to quantify the climate impact of this diversion, we used WRM tool, which is waste reduction model developed by US EPA. We applied it to primary data collected across 25,000 household and commercial units in 9 project locations, 4 in Himachal Pradesh, 5 in Uttarakhand from April 2024 to March 2025. Next, please. There are many established tools for estimating emissions in waste sector through IPCC guidelines to GHG protocol framework. For our purpose, WRM is particularly suitable because of its accessibility, being free, open access, one of the most credible and widely used tool developed by US EPA, which can assess both baseline as well as alternate scenario, gives a comprehensive coverage and captures emissions from different interventions. It gives us a consistent way of quantifying reduced emissions that can be directly coming into carbon dioxide equivalents. It is a simple tool for which our purpose aligned with our need. Next, please. While we talk about a workflow, we have 2 types of scenarios, one being baseline and one being improved scenario, where one is around what has happened when it is mostly dumped and another one when different interventions were taken into consideration. We feed in user inputs about tons of material given to different treatments, and WRM uses default values to calculate the emissions. Next, please. As with any model, certain assumptions guide the analysis. We adhered to standard conservative assumptions in line with WRM default. Because WRM is US-based, we applied a set of assumptions to match Indian conditions, like treating dump sites as unmanaged landfills using coal-heavy electricity factors, where proxy region West Virginia was selected, and adjusting decay rates. For our wetter climate, transport and anaerobic digestion values follow WRM default. Next, please. For material mapping, on the left are the categories into which Waste Warriors segregate its waste, which we then map on the available categories in WRM, shown on the right. Next, please. So here comes some interesting insights. The red one indicates baseline emissions, the green indicates alternate emissions. The delta value next to each pair shows the emission reductions achieved, which is calculated as alternate minus baseline. A negative delta means emissions have decreased, and which is what we all want. Each location from Himachal Pradesh and Uttarakhand is shown separately. Across all locations, improved waste management system led to significant emission reduction. And as we can see, like 13 metric tons of CO2 in baseline, and in total alternate, we have around 780 metric tons of CO2. So we have a total emission reduction of 2393 metric tons of CO2. That means when waste is segregated, composted, recycled, and moved away from mixed dumping, the carbon footprint drops drastically. Even decentralized interventions in small hill towns create large climate benefit per ton of waste. Next, please. While we talk about variation in material composition across locations, one consistent pattern across all sites is the dominance of mixed plastic in the waste stream. Only Harawala and Kempty currently, where we only segregate wet waste across all the units. So limited segregation in the other location means more organics and plastics ending up in mixed streams, directly affecting emissions. Material composition varies drastically by location. One size fits all solution won't work here. Some of the towns generate mostly recyclables. others mostly organics, and some have too much mixed waste. This waste DNA determines what solution will work where. There is a big recovery potential, but only if segregation improves. Next, please. While we see treatment placed by volume handled, recycling is the highest, especially for PET, HDPE, paper, metal, and glass. Co-processing in cement plant absorbs the majority of low-value plastics, mainly multi-layered plastics and thin films. Landfilling is limited to post-processing inert and non-recoverable material. Composting occurs when wet waste is segregated, but the volumes are quite smaller. So this hierarchy is what shapes the overall emission profile in our analysis. Next, please. So while we talk about GHG emission reductions from recycling, we see that negative value here means that emissions have reduced and ultimately contributing to climate benefit. Zero or positive values are something that gives little or no benefit. Here we can see like aluminum provides the biggest climate benefit. So we can say like recycling 1 ton of aluminum cans can give you about approximately 9 metric tons of CO2, which is the highest among all the materials. And we can say like, if you can recycle only one thing, we can make it aluminum. Paper, metal, and mixed recyclable also provide strong emission saving. All ranges between 2 to 5 metric tons of CO2 equivalents. Where glass and tires show very small benefits, they hover close to 0 metric tons of CO2 equivalent. This does not mean that recycling is useless, just that GHG savings are modest because glass manufacturing is already energy intensive. Though glass recycling is good for landfills and resource use, but not a major climate lever. With the overall emissions picture in place, Ashish will now dive deeper into material-wise dynamics. Thank you.
Thank you, Dr. Diksha. So in this section, we'll cover materials which we're getting on ground as part of our solid waste management interventions and their alternative treatments which we have applied and the associated GHG emissions impact. So as you can see in this graph, we have taken our top 4-5 materials which we get. So mixed MSW remains a reality despite our huge efforts around increasing awareness among households towards source segregation. We still get a lot of rejected waste, mixed waste, which ends up being at landfill. And there is a certain fraction of mixed MSW which goes for combustion. So please note here, combustion here, because of warm limitation, represents the co-processing. Typically, we send this type of waste for co-processing at cement plants. Mixed organics, right now it shows less proportion because it's only part of our 2 interventions at Kempi and Harawala. Only 2 locations are right now collecting segregated wet waste, and all of it is getting composted. Mixed plastics is a huge reality, and a huge proportion of mixed plastics is typically the non-recyclable material like multi-layered plastics, single-use plastics, other thin plastic packaging. Again, right now, there is no viable alternative to manage these material on ground, and we have to send it to cement plants for combustion co-processing. And then there is this mixed recyclables and other paper-based material, which we are able to recover quite well as part of our interventions, and we are able to channelize them properly to different recycling channels. Of course, many of them would be informal recycling channels. Now let's understand emissions impact of each of these materials. So coming to mixed MSW, so the graph here represents like what would be the emissions per ton of material across different alternative scenarios. And we can see mixed MSW when landfill results in way higher emissions than combustion. This is primarily due to the fact mixed MSW contains high proportion of wet waste, biodegradable material, which results in large methane emissions. And that's why probably these results are suggesting combustion is a better way to handle such material. Or we would say actually the ideal scenario would be to reduce such material at source by promoting source segregation, so that we really don't have to get into this debate of landfill versus combustion. Now coming to mixed plastics, since we do get a lot of non-recyclables as part of mixed place, excuse me, which we have to send it for combustion co-processing, that results, however, results in high positive emissions per ton. Recycling, of course, is favorable, which does result in negative emissions per ton for such material. Landfill, what we have seen from WORM results, like the emissions are almost nil. Like we see it here, only 0.02 carbon emissions per ton of material. So if emissions is really the concern, what we are suggesting here is probably we can explore scientific landfilling for these type of material, or other argument is probably we reduce this non-recyclable component by finding out sustainable alternatives, or changing the material itself, or redesigning them as per circular economy principles. So when recycling is most effective, we do get a lot of mixed recyclables. Many of it contains Tetra Pak and other materials, which we are able to channelize to recycling channels. And that's where we are able to get huge savings in terms of emissions. So we can see like 1 ton of mixed recyclables when landfilled versus recycled do results in huge net reduction in emissions. And similar is the case for paper waste product. Paper having high degradable organic component do result in high emissions when they're landfilled. So that's where recycling such material are very effective on ground. And that's where we are able to do it as part of our interventions as well. Now, looking at all of these channels across all materials, all locations, what we realized is that recycling remains the most effective methods in terms of net emission reduction per ton as per WORM. And one of the reasons for this is WORM does account for avoided GHG emissions from producing an equivalent amount of material from virgin input. So assuming if you're recycling per ton of paper or mixed plastic, like, so WORM is assuming like similar amount of material would be avoided when we're trying to produce it, when we're sourcing the virgin material for producing such consumer products. So it will reduce that, and it will lead to reduction in emissions. Landfill and combustion, what we see depending on different material types, it results in, of course, results in positive emissions, but the degree of emissions would vary on material which we are handling on ground. As we have seen for mixed MSW, combustion is lesser than landfill, while for mixed plastics, combustion is higher than the landfill. And combustion is the reality on ground. There are certain materials which we are unable to get viable treatment methods, so we do have to send it for co-processing and combustion. So now, so these were the results, and we did deep dive on these materials. Now let's understand some of the WORM tool limitations which we realized while we were calculating these results. So WORM is developed by US EPA, and as it reflects right now, what we see, it's not truly accounting the various factors for the Indian scenario, which includes climate, geographical conditions, and other processes and equipment used during waste management practices. There are certain type of materials like inert waste, sanitary waste, hazardous, or other non-recyclable material, which could not really be mapped to the WORM material category, which Diksha highlighted previously. Even the assumption around composition of mixed plastics. So WORM assumes mixed plastics contain 40% HDPE versus 60% PET. But while what we see on ground, the composition of our mixed plastics is largely different. And that's something we believe is a limitation of this tool. So baseline scenario of open burning and dumping. In our mountains, the places where we're working, open burning is a reality which results in black carbon, which is way more potent than methane gas. It has global warming potential of 1600 compared to methane, which is about 25 to 28. So that is something which is reality on ground, and this is something we are not able to incorporate in current WORM tool. We are sure if we incorporate baseline scenario of open burning and dumping, the actual net reduction in carbon emissions would be way higher. And then coming to waste management practices like co-processing, so WORM assumes combustion, which is typically the uh, controlled combustion, typically used in a waste to energy plant, wherever we are sending most of our non-recyclable material for co-processing. Even some places we do send material for upcycling. For example, at certain location, we do send material like MLP for upcycling, where these are converted into furniture or those boards. So that is something WORM, like scenarios like this, WORM, we cannot fully account in the WORM. So overall, what we realize, the results which are obtained from WORM tool are definitely indicative, but we can't really use them as a definite measure to account for GHG emissions, or while even submitting it to the government in terms of their inventory calculation. So how do we move ahead with this? So what we need as a ecosystem, as one of the player in this sector. So this is some of the suggestions from our side. We definitely need more India-specific emissions factors when it comes to electricity consumption, transport, even scenarios like landfilling, informal recycling. When it comes to India-specific material, we need local life cycle assessment studies which can showcase the true potential of emissions reduction. The tool should also incorporate India-specific material composition. As we have seen, what we get on ground, the material composition is very different from WORM. And lastly, like the local context in regards to geography, climate, or the waste management practices should be considered in emissions calculation. So ultimately, what we are seeking is an Indian equivalent of WORM-like tool, or it can be a better tool than this. So that's also one of the purpose of this webinar, to showcase our learnings, our insights with everyone, and then work towards this goal. So with this, we would wrap up this session. Thank you. We are open for questions now.
Thank you. Thank you so much, Ashish and Diksha, Dr. Diksha, for that wonderful presentation and very, very interesting insights. Some very detailed findings, very nuanced, I must say. A lot of different materials, lots of different number crunching there. And the WORM tool in itself having its own limitations and assumptions. And I'd see there has been a lot of questions that have been posed to us in the question and answer chat box. Rest assured, if we are unable to answer all your questions today, all our experts will be reading your questions, and they will be responding to those questions, and we will be sending an email out at a future date to all the participants with all the questions responded to. We'll begin. The first question I have in the Q&A chat box is from Puneet Kumar. Puneet asks, is there any technology or microbial formulation available in India to improve biogas generation or methane concentration in low temperature areas, which can provide stable, cost-friendly, and consistent results in the Himalayas? I'm not sure if this is a directly linked to emissions of solid waste. So I think we'll skip this, Puneet. We'll let the experts answer this question if they do have an answer to that. We'll move on to Tulika's question. Tulika Jain asks, many municipalities across India are creating waste to energy WTE plants to process waste. There is mixed evidence online about the impact of waste to energy plant. Some say that it is a major source of pollutants if waste is not segregated. What is the situation in India's current and upcoming waste to energy plants? Are we making the situation worse by using these as a silver bullet? Great question, Tulika. I will call out Dr. Sunil Kumar. Dr. Kumar, if you can.
Yes, I have seen this question. Question is very relevant, but the selection of waste to energy plants based on category of technology in different cities depends on the actual feasibility and DPR. Suppose we have evaluated DPR of Maharashtra, many cities, even a smaller city were interested for incineration facility. So that was not feasible. So unless and until good DPR, good feasibility with vetting by this reputed institution And if they are recommending particularly tier 1 and tier 2 cities incineration and other anaerobic digestion composting, then it will serve the purpose. So question is relevant. Still, waste to energy plants are needed, but its proper operation, maintenance, all these things are required for its successful operation. Thank you.
Thank you. Thank you, Dr. Sunil. We'll move on to Mamta's question. Got about 18 open questions. Chennai Climate Action Plan attributes 13% to the waste sector. Is there anyone here on the panel else who can dive and identify textile waste related statistics? Mamta, unfortunately, Waste Warriors does not work in the southern region of Chennai. I don't believe we have anyone here, but I'll let the experts take up this question and hopefully we can answer this question and respond to
I
you.
have already answered. In estimation of this greenhouse gas emission, different composition of waste matters a lot. So under the different composition, textile waste is also considered, but separate textile waste emission has not been identified and not been done by anyone.
Excellent, excellent. Thank you, Dr. Sunil. Mamta, I hope that answers your question. Moving on to Faisal's question, how many engineered landfills do we have in India? Dr. Kumar, I'll pose that question again to you. Do we have any engineered sanitary landfills?
Exact, I cannot say right now because many engineers landfill have come. Some are partial engineers, some are full engineers, but it is not more than double digit.
Great, thank you, thank you. Right, we'll move on to Anjali V. Raj's question. Which tool would be accurate for GHG emissions reduction calculation in the Indian waste management scenario? WARM is contextualized for USA. Places for plastic waste developed by the Circulate initiatives has a region-specific value, but still has a few limitations. Is there an Indian guideline for GHG estimations? I'll let Ashish Kapil take up this question. Ashish?
Yeah, thank you, Neeraj. Right now, as we mentioned, so we are not really experts at this. So we are also doing our own study around this. So right now, we have tried WARM, and parallelly, our team has already started working on a tool called Sweet, which is probably a potential tool for calculating such emissions. But Diksha also highlighted in one of her slides various tools. So we are going to, I think that's probably the larger tool set which we are going to explore over time. But I would also request probably Corinne or Paloma to answer around this based on your research. Thank you.
Sure. Thank you, Ashish. Indeed, I think the existing tools today do not fully capture the local context, and that was also highlighted in Dr. Kunar's intro speech, that the need for tier 2 and 3 IPCC emissions factors. What we call tier 2 and 3 are those emission factors that are adapted to the local context versus the tier 1 that are global emission factors that are published by the IPCC. And so most of the tools that you'll find online will have the tier 1 factors in them, but will not have these tier 2 and 3 factors, which have to be localized depending on your local contexts. Tier 3 is even more localized based on the organization specificities itself. So I think what you started doing using the Sweet tool will be very useful to assess the open burning and open dumping and landfill or poorly managed landfills emissions, because that's what this tool is designed to do. However, the tool might not cover all of the needs you have. So one of the things that following our exchange with the Waste Warriors, I've started a discussion within the ISWA working group on climate change, because I think it's a topic that could be tackled by the group to better guide local evaluation of these emission factors in different countries and share experiences between countries on this. This is the power of a network like ISWA.
I would like to say something.
Absolutely, please go ahead. Go ahead, Dr. Kumar.
I think this methodology, a lot of work has been carried out in India by different researchers. you can see the published paper where it has been used that land gem methods and improved default methods, triangular approach. We have carried out in 2004, but at that time we have told that India's specific emission factor is required. But now ministry is consider all those things, and they are going to fund it. But till now it was not done. Like West Warrior has already done a lot of good exercise and came out with warm. So similarly for Himalayan region, for different coastal region, different factors should be utilized. For that, a lot of study and research is required. Thank you.
Thank you, Dr. Sunil. So Anjali, we've had all our three experts, Ashish Kapil, Corinne Tromsdorf, and Dr. Sunil Kumar respond to that question. So I hope you've got your answer there. We'll move on to Amrita Day. Amrita asks, currently the large amount of waste is mixed, organic and inorganic, in landfills due to lack of proper segregation in India. Is it possible to separate that organic waste in landfills and then convert it to some resources such as biomethane or biofertilizer? Are there any existing techniques? Again, I think as far as this question is concerned, it is a little bit outside the scope of GHG emissions.
No, I will answer, Dr.
Sure, Dr. Sunil Kumar.
Amrita, your question is right. Under Swachh Bharat Mission 2, lot of efforts on biomining has been done, and dumped waste has been categorized at different category. If you go to Tripura, recently we have carried out auditing of all the biomining activities. They have separated all types of waste and they have reclaimed that. So things are available, technologies are available, and it is being done.
Thanks, Dr. Sunil Kumar. Yes, biomining, that's the key word, is what's been happening across to separate waste that is not segregated. We'll move on to Ashish.
If I can jump in, Neeraj?
Yeah, absolutely.
On this topic, so biomining is definitely very interesting, but to go back to that question on the biomethane, I think once organic waste has been put into the landfill, you cannot easily recover it unless and create an energy out of it unless you capture the landfill gas that is produced by the landfill. And that requires having engineered landfills with a sound cover above them and a gas capture system that is installed in that landfill. And then the gas needs to be purified because landfill gas is actually quite dirty and it needs to be purified before it can be used as an energetic resource as biomethane. So just for you to understand that, the importance of sorting organic waste up front before it reaches the landfill is that if you have that organic waste sorted, you can actually use a biomethanizer unit, an anaerobic digester, and produce biomethane that's already very much cleaner than if it was coming out of the landfill. However, it's going to be very difficult to have no organic waste at all in the landfills. So ISWA and the FSWP as well really encourages improving landfill practices to capture all landfill gas and purify it into biomethane when there is a business model that works, because obviously these activities are costly, and purifying that biomethane from the landfill gas is something that needs to have a market. You need to be able to sell that gas. However, it's a very powerful GHG mitigation lever, because otherwise that methane will be just let into the atmosphere, and that has a very strong global warming impact, in particular in the short term, over a 12-15 year period.
Thank you, Corinne. Yeah, absolutely. Prevention is better than cure, I think, is what we're trying to say, right? It's important to so segregate because the technologies available post that are quite challenging. And I believe there was a question earlier also that asked whether we did have any sanitary landfills, engineered landfills in the country. And I'm sure the experts will respond to that as well. We'll move on in the interest of time. We have many questions that I want to go through. Ashish Vaishnav asks, while material recycling, especially for plastics, is being pursued, would recycling be perpetual? If not, then wouldn't an end-of-life process be also required to be developed anyways to support this? Also, which typically could be waste to energy? Corinne, if you could come in and take up this question.
Sure. Indeed, plastics recycling is not endless. Plastics tend to lose their properties through the recycling cycles, especially when you only use mechanical recycling. And therefore, there's always a refuse stream from the recycled plastic plants. So some of the plastic can no longer be recycled, and it will need an outlet. And right now, the two options are landfills or waste to energy, typically through RDF production, because it gives you the flexibility to use it in different places. But again, you need a market for that RDF to be sold to. So in the case that was shared earlier, there's a cement plant that is close by that works well, but you do need an outlet for that material.
Thank you, Corinne. I think there was a question also specifically about typically for waste warriors, how far are the cement plants? Ashish, maybe you could take that up very quickly. How far are the cement plants from the waste warriors locations?
Yeah, I think that's a good question. So typically, I would say it's around 80 to 100 kilometers, but we do also face practical challenges like some of the cement plants which are nearby in the state of Himachal Pradesh. At times, they have enough capacity or they don't want to take in more waste. So there has been scenarios where at times they have rejected our request, and that is the time we also face a challenge because sending this waste is very costly affair. So in those cases, we have to explore outside Himachal Pradesh. I think one of the locations is probably in Rajasthan, where we also had to send this waste, and some in Punjab. So that's the reality. I mean, there is also a cost associated with it. But yeah, to answer that question, I would say about 100 kilometers is the average distance which we have handled throughout the year.
Thank you, Ashish. I know we still have quite a few more questions remaining. Unfortunately, in the interest of time, as we have, it's already 4 p.m. I'd like for us at this point, as we approach the end of our webinar, would like to invite Ashish Kapil from Waste Warriors for our closing remarks.
Thank you, Neeraj. So I, on behalf of entire Waste Warriors team and our partners, the ClimateRISE Alliance, would like to extend our sincere gratitude to all the speakers and participants who joined this session today. Dr. Sunil Kumar, thank you so much for sharing your expertise on India's waste sector landscape and nuances around GHG emissions accounting. Corinne and Paloma, your keynote really helped us broaden our perspective on global overview of the waste sector. And it also highlighted how international collaboration and shared technical knowledge are key to scaling up climate smart waste systems worldwide. So we truly appreciate you joining us today. Your session also highlighted the fact that although waste management might be a local issue, GHG emissions are not. They're truly a global issue. So that also came out from your presentation. So thank you so much. And from our team, Dr. Diksha and I were glad to present our findings on reduced emissions from on-ground interventions using the WARM tool right now. So as we can see, it reflects to some extent that better waste practices in Himalayas are already delivering few real climate benefits, and we are consistently working towards it. And to everyone with us today, we really thank you for your thoughtful questions, your reflections, your commitment towards advancing this agenda of calculating emissions, reduced or avoided emissions from solid waste interventions. Now, we would also like to mention that one of the purpose of this webinar is to move towards this roadmap where we can have this robust India-specific tool which we can use to calculate emissions from solid waste management interventions. And we invite collaboration, partnerships from research partners, our ecosystem partners, our other stakeholders, students, anyone who cares for this issue and really wants to work with us. We are open for the collaboration, and we really encourage you to write to us. So thank you once again for your time, engagement, and your partnership. Thank you so much.
Thank you, Ashish. I would like to finally, as we end this deeply engaging webinar, thank all our participants for your time today. I'd like to request you all to please take a moment to scan the QR code on the slide to access the form and share your feedback. Thank you, everyone, and have a great day.
Thank you. Goodbye.
Thank you.
Thank you so much.